Good morning, Tigers. So this is the last video lesson for Activity 2, Solving Equations. So today this is solving literal equations. This one, I'm hoping that when we watch this video and you start working it, it's not too bad. I've seen a lot of people struggle with this one because we are no longer solving with one variable, we're solving with multiple variables. And the solutions don't look like solutions. They still look like problems. So a lot of people struggle with this one, but if we can kind of get over this hump, we should be good. This is one that if you really need to try the assignments for. You really need to work the assignment on this one. We've got to get through. This is when you just got to practice, okay? The more you practice, the better you get. All right, so let's start with annotating our learning target. So I'm going to go ahead and pause the video, or you go ahead and pause the video and take care of that. Okay, so double check, make sure you've annotated correctly. Again, these are the same ones we've done all Activity 2. If you remember, I've been telling you we're going to get to solving literal equations. We're going to get to this. That's Activity 2.5 or Lesson 2.5. Well, that's where we're at. So this is the biggie today. So the one we're really working on. Okay, so we're going to go ahead and start on task 1 together. So task 1, I want you to go ahead and do number 1. Just list a few formulas you remember from previous courses. So go ahead, if you can think of any formulas, go ahead and list them now. And I'm going to list a few as well. Okay, so I've listed 2 so far. I have the Pythagorean theorem, a squared plus b squared equals c squared. That's for finding the missing side of a right triangle. And then I have the area of a triangle. Area equals half of base times height. We could do area of a circle, which is pi r squared. You could do circumference of a circle, which is 2 pi r. And there's lots of other formulas you could do. And there's tons of science formulas, like speed is equal to distance over time. That's a good one. And there's tons more. This is what I could think of off the top of my head. So if you notice, most of your formulas have more than one variable. Pythagorean theorem, you have 3 different variables. You have the length of one leg, the length of the second leg, and the length of the hypotenuse. In this formula, you have speed, distance, and time. All 3 of those are different variables. So formulas have more than one variable, and that's where solving literal equations come in. It's basically just rearranging your formula. So like if I were given the area of a circle and I want to know what the radius is, I could solve for r and get radius equals blah 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 instead of area equals blah blah blah. Okay, so let's look at number 2. It says consider the formula for density. How could you use this formula to find the mass of an object? So I know that if I take I can find density by dividing mass by volume. Well, if I can get density by division, if I want to get mass by itself, what could I do to density and volume to get mass? Well, I could multiply. I could do velocity times distance and get mass. So pretty much what I've just done is solved a literal equation. To get mass by itself, I multiplied by velocity on each side. Okay, and that's kind of basically what we're doing, is we're getting a different variable by itself. So a lot of people are going to get tripped up because this does not look like an answer. It looks like another problem. And it kind of is, but the goal of solving a literal equation is to get one particular variable by itself. It's not to get x equals 4 or y equals 47. It's you're going to get something like y equals 3x plus 7, or x equals 2/3 m minus 18b or something. So you're going to get, it's going to look like another problem. It's not going to look like an answer. If you can get over that hurdle, you should be okay with these. Okay, so let's look at 3. And it just says, follow along with your teacher as we solve the following literal equations together. So this is your first time solving a literal equation. So I'm not going to ask that you do this on your own. I'm going to do this with you. So this says solve 4x plus b equals 12 for x. So I want you to notice it says solve it for x. If it doesn't tell you what variable to solve for, you cannot solve it. If it says just solve this, well, what does that mean? Solving usually means find a solution or find something that can go into this. But when you have two variables, there's not just a single solution. So when it says solve for x, this means get x alone. So that's the goal, is to just get x alone. Okay, so I'm going to rewrite my equation. So I have 4, and I'm going to put x in a different color so we just keep track of it. So we have 4x plus b equals 12. Okay, so let's discuss what's being done to x. This is where a do and undo list comes in handy. So we'll do that to the side. So what am I doing to x? Well, the first thing I'm doing is multiplying by 4. So times 4. And then the second thing I'm doing is adding b. So how do I undo these two things? Well, how do you undo addition? You subtract. So we'll subtract b. And then to undo multiplication, we'll divide by 4. Make sense? It's the same thing we've been doing. The only difference is instead of it saying like plus 5, we'll have plus b. Okay, so let's start solving. Let me do that in this color. Okay, so the first thing I want to do is subtract b. So let's do that. Okay, these cancel and I'm left with 4x equals. Now here's where it gets a little more confusing. Can we actually do 12 minus b? We can't. We don't know what b is. So I can't say 12 minus b equals 8 because I don't know that b is equal to 4. So I can't say that it equals 8. We don't know. We don't have what b equals. So we can't actually subtract it and get a number or get a variable. So what I'm going to have to do is just write 12 minus b. And you just leave it alone. So a lot of people get confused by this, but if you think about it, you're not actually doing the math. You're logically subtracting it, but you're not actually subtracting anything. You're just kind of writing, okay, when I know what b is, then I'll subtract it. So you're rewriting your formula. You're not physically doing any computing. So I get a lot of people who ask, can I have a calculator for this? I'm like, calculator's not going to help you because you don't know what b is. A lot of people actually use the graphing calculator and say, well, when I did 12 minus b, the calculator gave me 14. I'm like, well, that's because someone put in your calculator that b equals -2. The calculator does not know what your variable is. I can program it to say whatever I want. So don't try to put variables in the calculator. It does not work at all. You have to define what your variables are. So that's, that might seem off topic, but I just want to make sure that we're not trying, you cannot put these in the calculator. Let me just throw that out there. Okay. So then to cancel out times 4, I'm going to divide by 4. All right, so 4 divided by 4 cancels, and I'm left with x equals. Okay, so you could leave it like this, but we can also simplify a little bit. So 12 can be divided by 4, and you would get 3. B, we don't know what b is, so we can't really divide it by 4, so we're going to have 3 minus b over 4. And that is our answer. Again, it doesn't look like it should be an answer. It looks like a problem. but that's okay. It's fine. We have what x equals. X is going to equal 3 minus whatever b is divided by 4. And if we figure out what b is, like if someone tells me, hey, b is going to equal this, well, then we can get a number for x. But right now, we just have x by itself. That's the end goal, is to get x by itself. All right, so let's do this one. Now, this is the same equation. I want you to notice that these two equations are the same. But this time, instead of solving for x, we're going to solve for b. So this time, we're going to get b alone. Okay? So let's rewrite our equation. We have 4x plus b equals 12. And we'll make our do and undo list. So now I'm looking at b. So what am I doing to b? The only thing I'm doing to b is I'm adding it to 4x. So the only thing I'm doing is adding 4x. And that's it. That's the only thing I'm doing. So the only way to undo that is to subtract 4x. Okay? So let's do that. Let's subtract 4x from each side. These will cancel, and you're left with b equals 12 minus 4x. Again, I can't combine the 12 and the 4x because this has an x and this doesn't. So my final answer is just b equals 12 minus 4x. And that's it. You're done. How nice is that? And that wasn't terrible. And that's how you solve a literal equation. Okay, so I want you to take a minute to pause the video. Answer 4 and 5 for me. I can't answer those for you. And then go ahead and give yourself some time to, well, actually, let's just answer 4 and 5 for now, and then we'll come back for task 2. Okay, so hopefully you've answered 4 and 5. Task 2, I do want you to do 6, 7, and 8 on your own. You can set up an undo list if you want, or you can just start solving like a normal equation. Just treat the letters like you would a number and do the exact same steps. Just notice it does say solve each equation for x. So your end goal for all of these is to get x alone. So go ahead and pause the video and try 6, 7, and 8. Alright, so I've gone ahead and I've worked it out. And I've worked out the whole, like each step, so that you can see what I did. So, number 6, you want x by itself. So we subtracted 7 from each side. Got ax equals -4. Divided both sides by a. And got x equals -4 over a. Number 7, added 10 to each side. Then divided by c. And we should get x equals 5 over c. And number 8, we subtracted d from each side, and that leaves us with -3x equals -9 minus d. Then divide both sides by -3, and we're left with x. -9 divided by -3 is +3. And then here, negative and negative cancel, so you should just get d divided by 3. All right. If you have any questions, make sure you let one of your teachers, your teacher know, so that we can clarify and help you with any of this. And let's move on to the next page. Okay. All right, so let's talk about number 9. Is the equation 2x plus 4 equals 5x minus 6 a literal equation? Why or why not? So let's look at the definition of literal equation real quick. That would be right here. A literal equation has more than one variable, and the equation can be solved for a specific variable. Okay, so let's look at this. Does this equation have more than one variable? It does have 2 x's, but that's the same variable. I can subtract 2x from either side and have 3x, and then we'd only have one variable. So this one is not a literal equation. It only has one variable, and that is x. And then I'm going to put in brackets, even though that variable appears twice. Okay. Oops, that was kind of crooked. All right, number 10. Why can I not answer the following problem? Solve the equation 2x plus b equals 34c. What is wrong with that? There's something wrong with the way that problem is worded that's not going to allow me to answer that. So give yourself a minute to think. Okay, so the reason that we cannot answer this problem, it didn't tell me what variable to solve for, so I don't know if I'm trying to get x by itself, b by itself, or c by itself. So the problem does not specify which variable to solve for. We can leave it there. Okay. Number 11, describe the similarities and differences between solving an equation containing one variable and solving a literal equation. I don't know why I gave that a question mark, because it's not a question, it's a statement. So describe the similarities and differences between an equation with one variable and a literal equation. I'm going to leave this one blank, and I'm going to leave this for you to answer. So if you like, you can pause the video and answer it. Okay, so again, number 11, I'd like for you to on your own, and maybe we can discuss that in class tomorrow, or whatever day my next class, whatever day we'll see you. Okay, task number 3, rearranging formulas. This is the same thing as solving a literal equation, but now we're going to have a real world formula to play with. So we are given the equation v equals v sub 0 plus at, and that equation is the formula for velocity in meters per second of an object after t seconds, where v sub 0 is the object's initial velocity in meters per second, and a is the acceleration in meters per second squared. Okay, so that's a mouthful. So let's just, it says, number 12, read the problem a second time. What do you notice? What do you wonder? Again, this is one for you to respond to. So I want you to look at just reread it, because I know that was kind of, it probably went in one ear and out the other the first time. So go ahead, reread the problem, and jot down some notes. Pause the video while you do this. Okay, so now that we had some time to do number 12, let's look at number 13 together. All right, so it says list each variable and tell what each variable represents. So the very first variable I have is v. Okay, this is velocity in meters per second. So v is for velocity, and we'll abbreviate the unit. So it's in meters per second. Okay. And then our next variable is v sub 0. So a lot of people get confused by that. This character, so you have a 0, a little bitty 0 by the v. if this were at the top, you would know it's an exponent. When it's at the bottom, it's just saying that we have two of the same variable. We don't want to create, this is a real formula. This is a physics formula. And if you have two different velocities, you usually have like a 1 and a 2, or this one's blank and this one's 0. And it's so that you don't get these two things confused. So they both represent velocity, but they should be worth two different values because they're two different velocities. So instead of coming up with another letter, which is what most math people would do, but when you get into sciences, they use the same variable because I think each letter represents its own unit or its own variable. Like S will always be speed, T will always be time. K is, now I'm not sure what it is in physics, but K is like a constant. So there's A is normally an acceleration. So they don't reuse letters because they don't want them to get confused. So what they do is if you have two velocities, you just have a velocity 1 and a velocity 2. So I've been saying V sub 0. This, when it's down low, it's called a subscript. So it's pronounced V sub 0. Now, I will tell you, I never said it right as a student. I always was like V's 0, like V's of 0, and I didn't know it was sub. So, I mean, if you don't say it correctly, I'm not going to be all over you, but I'm just letting you know. So this is not just velocity, this is the initial velocity. I should have written that. I was talking instead of paying attention. So this is my initial velocity, and if you don't know what that means when you start calculating, like what was your speed when you started, or what was your velocity when you started. So we have velocity and our initial velocity. This will also be in meters per second. Our next variable in this formula is an A. A is the acceleration. In meters per second squared. And then our last is T for time, and that is in seconds. Okay, so we have all four of our variables. Okay, 14 says solve the equation for A. So we want the acceleration by itself. So we have V equals V sub 0 plus A times T. Okay, and just another quick note, when you have V sub 0, that 0 is not necessarily considered its own number here. It's just saying that it's just making sure we know it's a different variable. So a lot of people are going to try to do like, well, V times 0 is 0. We're not multiplying. This is just saying this is velocity 0, and then this is just current velocity. So I'm just throwing that back out there. All right, so let's look at, if you would like to make a do and undo list, we should do that now. So let's look at A. So what is happening to A? The first thing I notice is that A is next to T, so that means we're multiplying by T. And then I have an addition sign, so it's being added to V sub 0. And then that's it. So to undo this, we're going to subtract V sub 0 and divide by T. All right, so let's do it. So first thing we want to do is subtract V sub 0 from each side of the equals. And this is going to become V minus V sub 0 equals A times T. All right, so how do I get A by itself now? So I've got A times T. To undo multiplying, I divide. So we're going to divide both sides by T. These cancel. And we are left with V minus V sub 0 over T equals A. If you're OCD like me and want A in front, here we go. Boom. All right, and then number 15 asks, determine the acceleration for an object whose velocity after 15 seconds is 25 meters per second and whose initial velocity was 15 meters per second. Okay, so all that means, that's a lot of wording, but we know what each variable means, and we have values for every single variable except for acceleration, because that's what we're looking for. So we should have A equals, first thing I need is the velocity, V. So our velocity after 15 seconds, we don't need that just yet, is 25 meters per second. So we have 25 meters per second. And then our next thing we need is the initial velocity. The initial velocity was 15 meters per second. And then our time, T, was 15 seconds. So we should have A equals 25 minus 15 is 10 over 15. And 10 divided by 15 is the same as 2/3, which if you were to do that as a decimal would be 0.6666 repeating. And that would be our acceleration. So if we wanted to rewrite this, our acceleration is, now remember we have our units too, meters per second squared. So our acceleration is 0.66 meters per second squared. So yeah, so that's our acceleration. That's how quickly our speed is changing. Okay. So I know that was a lot, but the steps are the same. I think where this one got kind of hairy was, okay, well, what's acceleration, what's velocity? You don't really need to know that. You just need to know which variable represents which, and then plug in and simplify. All right, so let's go on to the last page. And this is some individual practice. So here, you are given some formulas. So the name of the formula and what variable to solve for it. And then here's where you're going to show your work. You can check your answers on the keys online. And if you have any questions, please let your teacher know. I'm going to go ahead and end the video here. Good luck on this section, and make sure you just practice, okay, guys? Hope you have a good evening. Thank you for paying attention.